Hello class, these are our notes for P2.1 factoring. So this is like a pre-unit 2, and we're just kind of going over all of the things that we should know about factoring. We're trying to assume that you might need a little refresher here. But this is not meant to teach factoring from the ground up, right? This is meant like, hey, you already understand factoring. We're just going to review it all real quick. So our rule number 1 of factoring, this is super important, is you factor out the greatest common factor first. And we're just going to try that in a couple. So if I have a 4x squared plus 18x, I can see that 4 is a 2 times 2, 18 is a 2 times 9. They both also have x within them as well. So I'm going to factor out a 2x. So if I have 4x squared and I factor out 2x, I'm left with 2x. 2x times 2x, if I think about distributing it back in, would make a 4x squared. 18x divided by 2x would just be a 9. So when we factor, we are dividing something out. We call it factoring out, but really it's dividing. It's kind of like the opposite of distributing, or the inverse of distributing. So instead of multiplying a common factor in, I am dividing a common factor out. The next one, let's see, they both have an x and a 2. So I'm going to go ahead and factor out a 2x. And that would give me 3x squared. Again, 2x times 3x squared, 2 times 3 is 6. X times x squared makes an x cubed minus. And then if I think about dividing out that 2x from 56x, 56 divided by 2 is 28, and the x is now sitting in front. On the last one, 3, 12, 15, I can factor out a 3 from everything. And then I'm left with a trinomial. And I could remember, and we're doing this like kind of the next step for part 2, I could remember that 5 times negative 1 makes 5, and 5 plus negative 1 is 4. And so I could factor this as x plus 5 times x minus 1. So I could keep factoring it. And that 3 just stays out. So one of the common mistakes I see of factoring is students do this. They go through and they divide everything by 3, and then they say, well, now I just have x squared plus 4x minus 5. But we cannot divide by something like that unless we have an equation on both sides. And I do not have an equation, so I cannot divide out a factor and then throw it away. Because if I think about the rules in math, this line is not equivalent to this line. They're not equivalent anymore. And that's because there's no equal sign. So you can't just like factor something out like that and throw it away. All right, on the next one, let's see. We are looking at factoring x squared plus bx plus c. So this is when I have that leading coefficient of 1. This is my easier kind of factoring. So first we set up our factored form. So I'm going to do that over here. And because it's just an x squared, they both have an x. And then I need numbers that are going to add to b and multiply to make c. And usually we start with the multiply part of it. So I want to think, what could I multiply to get 3? And there's only a couple ways to do that. 1 times 3 or 3 times 1, really the same thing, right? So this is a 3 times a 1. And when I add those factors, I do in fact get the middle term. So that means I'm going to have an x plus 3 times an x plus 1. And you could switch the order of those factors. X plus 1 times x plus 3 is also the same thing. And you can check by multiplying. So if I multiply this out, x times x is an x squared, plus x times 3 is a plus 3x, plus 1x, plus 3, which is x squared plus 4x plus 3. And that's what I started out with. So it does in fact check. Couple for you to check your understanding on. Before you try on your own, my hint on number 2 was make this an x squared plus 0x minus 9. Then you're looking for things that multiply to make negative 9 and add to make 0. So go ahead and pause it now and try these on your own. All right, so hopefully you've been able to factor 1 and 2. 1 is a little bit tricky because there's so many different factors of 60. There's 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 6, 5 times 12, 6 times 10. So lots and lots of factors. What I usually do is write them out and don't worry about signs, and then think about how if I want my middle term to be negative, it means my bigger number needs to be negative. So I just go through and add all those in. And then I'm looking for something that adds to make a -4. And that would be the 6 and the -10. So I'm going to write this as an x plus 6 and an x minus 10. Remember, we can always write our factors in different orders. The second one, in order to get a 0 in the middle term, it would have to be a -3 and a +3. So I'm going to write down x plus 3, x minus 3, because a positive and -3 would add to make 0, but they would multiply to get a -9. We're going to just try multiplying using the box method really quick. So first was greatest common factor. Second was just factoring the kind that we probably remember the best. And now we're looking at box method, and that's because we're going to use the box method to do some factoring. So 2x minus 3, I'm going to write a 2x and a -3. Across the top, 3x squared minus 5x and 2. So these are the things that I am multiplying together. All right, and so I've got, these are my factors. My factors go on the outside. And then I want to use the box to go through and do all of the distributing and see if I can get this to work. Right, so the way we do this is every time I fill out a box, I'm looking for what it touches, and that's what I'm multiplying. So when I want the stuff that's like in this square right here, I'm looking at multiplying 3x squared times 2x, because that's what would be like in line with that box. So 3x squared times 2x is a 6x cubed. And then I'm going to move over and do my next one. And so to get this one, I would have to multiply the 2x and the -5x. So that's going to be a -10x. And the next one is a 2x times 2 is a 4x. So it's kind of like I've taken the 2x and I've distributed it all the way through. That's basically what I've done. Okay. And I'm trying to erase my extra marks here, but I just think it's going to make a mess. Maybe not. Come on, buddy. All right, let's see if I can do like a real fine point eraser here. Yeah, that's what I needed. Okay, so now I'm going to go through and do the second row. So the second row is the equivalent of taking that -3 and multiplying it by everything, right? And just organizing it in this box. So that's going to give me a -9x squared. So remember, I'm multiplying the 3x squared and the -3. And then -3 times 5x would be a -15x. And then -3 times 2 would be a -6. And I just feel like I've made a mistake on there somewhere. Oh, I know what it is. Because a -3 times a, I totally missed this sign right here, huh? This -5x. That's going to make it a plus right here. So it looks like I caught it in one row, was kind of looking at it, and forgot it in the other. It looked different than when I did it in class, so I need to check. So if I do this right, my like terms should always be in these nice diagonals. And this also helps me to keep from making mistakes. Because what I notice is 2x times -5x. Oh, now I'm seeing another mistake. This should have been an x squared. And I really like this part about it. You know they should line up. If you don't have like terms, go back and check over, see what you've done. Our last step is just to add all of our box entries. So I have a 6x squared, or 6x cubed, sorry. That's going to be my first one. And then -9x squared, -10x squared is a -19x squared. 15x, 4x makes a plus 19x. And then my last one's -6. So we're just making sure we put those like terms together. And again, they should be in diagonals in the box. So we can use our box method to do factoring. So remember, the factors were the part that was like on the outside. So what I would do is I would fill the stuff I have onto the inside of it, and then I would find those factors. So we're going to factor the kind that's more difficult. This is the one where we always lose students in Algebra 1, and they think this is really hard, and they just kind of give up. So I think this is the year though, right? You're older, you're wiser. This is the year in Algebra 2 where we're going to get really good at this. So first we're going to check to see if we can factor out a greatest common factor. And we can here, right? 9, 6, 15. We can divide a 3 out of all of them. So if I divide a 3 out, I factor it out, put it in front, I'm going to have 3x squared minus 2x minus 5. So I've got my 2 by 2 box created. We want to write the squared term in the top left corner and the constant term in the bottom right corner. So we start up here with the 3x squared. and the negative 5 goes over here. All right, so the missing diagonal adds to make the middle x term, right? So whatever goes in this box and this box, together they would have to combine and make negative 2x. But we don't know what they are, right? Because this is that one where we can't just look at what adds to make the last term, or multiplies to make the last term, adds to make the middle term, because it's more complicated. We have that 3 in there. We have a leading coefficient that's not 1. So whatever our missing diagonal is, it's going to, this is kind of worded weird. Whatever goes in these two boxes, when we add them together, is going to have to be the product of my diagonal that I do have. So the 3 and the negative 5, when I multiply those, I get negative 15. So I'm just kind of ignoring that x squared. This makes a magic number, and I got this magic number by multiplying the 3 and the negative 5. So my coefficient on the leading term, my constant term. Sometimes they call this a master product. Might be a definition that, or not a definition, a vocab word that you hear. And they use this in a lot of different kinds of factoring for this kind of factoring. And whatever we have left in those last two boxes, it's going to add to that product. And so I think I'm going to write adds. They wrote a different word here in the blank, but I just think it's kind of awkwardly worded. So that's what we're going to go with. So I know that whatever goes in those two boxes that's missing, it has to multiply to make the negative 15, but add to make the negative 2. And that's the weird part, right? So I feel like adds, multiplies, like this is just kind of weird. So my x terms have to multiply to make negative 15. So I need two numbers that multiply to make negative 15, but add to make negative 2. So now I have to find two numbers that multiply to the negative 15 and add to make negative 2. So multiplies make negative 15, adds to make the negative 2. So let's think about that. That's going to be a negative 5 and a positive 3. So negative 5 times 3 would multiply to make negative 15. Negative 5 plus 3 would add to make negative 2. So I'm going to have a negative 5x and a 3x. And it doesn't matter which box I put those in. I could totally flip that around, and I could put the 3x over here and the negative 5x over here. It will work no matter what you do. It doesn't matter if you switch them around. As long as you pick the right two numbers, you're good to go. I'm going to get rid of all that extra stuff. Okay, now I want to look and I want to find the factors. And the way I do that is I look at my rows and columns and I find greatest common factors. Oops, sorry about that. So first I want to look at this row, 3x squared and 3x. And I want to think about what do those have in common. Well, they have a common factor of 3 and an x, so I'm going to write a 3x out in front. I don't worry about what's left. I just factor out what they have in common. When I look at the negative row, I have a negative 5x and a negative 5. So I'm going to write a negative 5 out here. So just to kind of give you the heads up, whenever there's a negative like out here at the edge of the box, that's when it's a negative 5. Okay, they have to match. I always talk about how these negative signs have to be like touching, like right next to each other. They have to be for the terms that are next to each other. Now I want to look at the tops of the columns. So remember, the factors, if you look at the last problem, the factors were out in front here and they were above here. That's what I'm trying to find. I'm trying to find those factors. So now I'm looking at my columns. I'm looking at 3x squared and 5x. What do they have in common? They have an x in common. So I'm going to put an x on top. And then I want to look at what do these guys have in common? Well, they have nothing in common. So I'm just going to write a 1. Now, the reason I'm not making that negative is that the 3x is positive. 3x is like the little square that's touching the 1, and their signs have to match. So now I have my factors. My first factor, let me erase my old circles so I can do new circles or something. My factors that I have now are the 3x minus 5 and the x plus 1. That's my factors. So 3x minus 5 and x plus 1. And I could totally check that back if I wanted to. Now I'm forgetting something. I'm forgetting that I had factored out a 3 originally. So that 3 needs to go there as well, because that equal sign has to have equality. If I go through and multiply out on the right-hand side, it has to equal the left. And the left-hand side has a 9. So I need to multiply it all out and make sure it's a 9 again. I think what we did, let's see, we did rewrite with parentheses here. Okay. I know it says check your understanding. Usually I have you do these on your own, but we're going to do 2 together first. Okay, so let's do these 2, and then you could try 1 and 4. So let's go ahead and write them in. 2x squared, -9. That's my first step. My next step is to multiply and get that magic number. 2 times -9 is -18. Now I want to look at things that multiply to make -18, but add to make 3. So I'm basically ignoring the 9 right now. So things that multiply to make 18 would be 1 times 18, 2 times 9, 3 times 6. Because I want to add and make a positive, the smaller one would have to be the negative. So I want to see which one is going to add to make positive 3, and that's -3 and 6. So -3 times 6 is 18. -3 plus 6 is 3. So I'm going to factor this as -3x, positive 6x. And if I switch the box, it just switches where the factors go. Okay, so if you put those in a different spot, it's fine. It doesn't matter. Now I want to look across and figure out the common factors in my rows. So this row right here, they both have an x. I'm going to put an x in front. This row right here, they both have a common factor of 3. You get faster at looking at those, okay? It's going to take some practice. And we're looking at a common factor, but we're not worrying about like actually dividing it out, right? We're just writing down what it is. Now I want to look vertically. So when I'm looking at my first column, I have a 2 and an x in common. My second column, oh, this is where that negative is. I'm going to have to factor out a -3. So last step is to write my factors down. My first factor is the x plus 3. My second factor is the 2x minus 3. I can write them in either order. It doesn't matter. And you could always multiply them back to check. 2x times x, 2x squared, 2x times 3, plus 6x, minus 3x, minus 9. So it makes 2x squared plus 3x minus 9. You can always check your answers when you're factoring. It's really easy to do. So you might not have realized this, but I definitely quickly looked at this when I first started the problem. I just do it so much it's automatic. And I looked at how there was a 2 in front of the x squared and checked my other numbers to see if I could divide a common factor of 2 out, and I could not. But just know that's something that we're always supposed to be doing. For 3, I notice I can divide 10 out of everything. So that's my first step. I'm going to put a 10 in front, and then I'm left with x squared plus 8x plus 7. Now I could totally use a box on this, but because I have nothing in front of my x squared, there's no leading coefficient other than that imaginary 1 that's always sitting there, I don't have to use that factoring method. I can look for what multiplies to make 7, adds to make 8. That is going to be a 7 and 1. So 7 times 1 is 7. 7 plus 1 is 8. So that's what we should get. So you're going to go ahead and pause right now and try the other 2. Sometimes I just write up answers when I'm done with something. These ones I'm actually going to go through explain. But go ahead and try 1 and 2 on your, 1 and 4 on your own right now. So for problem 1, start out again, 2x squared, 5. Multiply and get your magic number. 2 times 5 is 10. Now I'm looking for things that multiply to make 10, add to make 11. 10 is either 1 times 10 or 2 times 5. 1 times 10 is going to be 10. 1 plus 10 is going to be 11. So I need a 1x and a 10x. And it doesn't matter. I could totally switch those 2 boxes around. It would not matter. So now I want to go rows and columns and divide stuff out. So in my first row, 2x squared and 1x, they have an x in common. In my second row, 10x and 5, I could divide out a 5 from both of them. So we're just looking at basically like a greatest common factor there. All right, now I want to go to columns. So 2x squared and 10x, I would factor out a 2x. 1x and 5 have nothing in common. I'd factor out a 1. Then I write down my factors. My factors are the x plus 5 and the 2x plus 1. Okay, last one. Let's see, I've got a 3x squared and a 4. And we're looking for things that multiply to make 3 times 4 is 12. So it's got to multiply to make a 12, but adds to make a -8. So that means I'm going to have 2 negatives because it's got to multiply to make a positive. So negative 1 times negative 12, or negative 2 times negative 6, or negative 3 times negative 4. So it looks like negative 2 times negative 6 adds to make 12, or sorry, multiplies to make 12, but adds to make a negative 8. So negative 2x, negative 6x. All right, now we're going to look at our rows and columns. So my first row, they have an x in common. Second row, they have a negative 2 in common. Remember, if my negative is here on this outside, like touching the edge, then this has to be negative also. You got to have those two negatives right next to each other. When I'm looking at my factors for my columns, let's see. I've got 3x squared and 6x. That's going to be a 3x. And then I've got a negative 2 and a 4, so negative 2. So my factors are 3x minus 2 and x minus 2. And again, you could multiply those back and check them. Next pattern is difference of squares. A binomial, so let's remember that binomial means two terms, has the form a squared minus b squared, and that's going to factor as a plus b times a minus b, or vice versa. You could put the minus one first. So the terms in each binomial are the square roots of the original. So the way I do this is first I look, okay, there's two terms, and then I check to see, are they perfect squares? X squared is a perfect square, 49 is a perfect square. So then I set up two binomials, put x first in both of them. And then in my factors, the square root of 49 is 7. So I have a plus 7 and I have a minus 7. Next one, I'm going to do the same way. 4x squared is a perfect square, 1 is a perfect square. Two sets of parentheses. The square root of 4x squared is 2x. One's plus, one's minus. It doesn't matter which order. Square root of 1 is 1. Next one, same thing. 9x to the fourth and 4x squared are both perfect squares. So square root of 9x to the fourth is 3x squared. One of them is positive, one of them is negative. Square root of 4y squared is 2y. So this one's really easy if you can identify it. So remember, you got to have two terms, and it's got to be two different squares, perfect squares. That's why we spent so much time recognizing perfect square patterns in the last chapter. So next says solve by factoring. And this is the one that we didn't get to in class. It just was going too long. So we want to rewrite the equation so there's a 0 on the right-hand side. We are going to factor the left-hand side, and then we're going to use zero product property to solve. Zero product property is when we multiply two things and get 0, then either A needed to be equal to 0 or B was equal to 0. One of the two things had to be a 0 to start with. A product of factors is 0 if and only if one of the factors is 0. So what they're saying is if I multiply 7 by something and I get 0, it had to be a 0, right? That's the only way to get 0 is to multiply by 0. Okay, so I would solve this equation by first adding 7 on both sides. So then I have 2x squared plus 15x plus 7 is equal to 0, and then factoring that. Because I cannot divide a 2 out of everything, and in this case, because of the equal sign, I could just divide it out and it would disappear, right? I could divide it on both sides. 0 divided by 2 is 0. I need to actually factor with that 2 in there. So this is going to be my box style factoring. So I put the 2x squared in the upper right or left corner, the 7 in the lower right, and then go ahead and multiply. 2 times 7 makes our magic number 14. We're looking for things that multiply to make 14, add to make 15. So that's going to be 1 times 14, 1 plus 14. So in my missing diagonal, I'm going to have a 1x and a 14x. Now we want to see what's in common. So in my first row, that's an x. Second row, it's a 7. Looking vertically, I have a 2x and nothing, so a 1. So my next step would be to say, well, now I've got this thing factored. I'm going to erase these to get them out of the way. Actually, maybe I'll write them up here because I do think they were important to the problem. So I would have, now that I have it factored, I would write that it is 2x plus 1 times x plus 7. Factors can be written in any order. That was equal to 0. So I would set each of those factors separately equal to 0. And then I would have to solve them both. So I'm going to subtract 1 and divide by 2. So x is equal to negative 1/2. The second one, I would subtract 7. So my answers are x is equal to negative 1/2 or x is equal to negative 7. So there's 4 here that you could check your understanding on. I really like now we've got some like mixed factoring styles. If I were you, I'd pause it, try it on my own, and then we'll come back together. A couple of them are kind of tricky. When all the factorings mixed together, it can be more difficult. So number 1, I would subtract 5 on both sides so that I have 6x squared plus 13x minus 5 is equal to 0. And then what I would do is I can't factor anything out of all of them, so I would go ahead and set up the box. And this would be my 6x squared. This would be my negative 5. Magic number is negative 30. I'm looking for things that multiply to make negative 30, add to make 13. That's going to be a 15 plus negative 2, or 15 times negative 2. So those would add to make a positive 13, multiply to make a negative 30. So let's go ahead and fill them in. 15x and negative 2x. So rows and column, what's in common? So 6 and 15, I feel like that's a little bit tricky. That's going to be a 3x. My next row is just a minus 1. And then columns, I would have a 2x and a 5x. Or sorry, just a 5. Yeah. So let's go ahead and write down our factors now. We have a 3x minus 1 times a 2x plus 5 is equal to 0. Add 1, divide by 3. They don't give you a lot of space here, sorry about that. Second one, I would need to subtract 5 and then divide by 2. All right, now the second one, I only have 2 terms. So if I only have 2 terms, I'm not really sure what's going on, right? And 2 and 72 are not perfect squares. But what I can do is I can factor 2 out of everything. And then I'm left with x squared minus 36. And really, I could just divide that 2 on both sides. Okay, now I'm left with 2 terms, but they're both perfect squares. So now I can factor. So square root of x squared is an x. One's a plus, one's a minus. Square root of 36 is 6. And then I'm going to solve both of those. And I've got x is equal to negative 6, or x is equal to positive 6. For number 3, I can see that's going to be my traditional x squared x number again. It looks a lot like the number 1 that we did, so let's add 9x on both sides. This means I have a 3x squared plus a 9x minus 84. Man, can I divide 3 out of all of them? I think I can, and that would definitely make my life easier. So let's go ahead and divide both sides by 3. Or let's factor out the 3 first. That's going to be an x squared plus a 3x minus, let's see, that's going to be a 28. Right, so now this is easy style factoring again, right? I'm looking for things that multiply to make negative 28, add to make 3. So that's going to be a 7 and a minus 4. And then when we set things equal to 0, because the 3 out here is just a constant, when I do zero product property, I don't worry about it, because what I mean to do with zero product property is take all my things that are being multiplied and set them equal to 0, but 3 can't equal 0, so you just kind of ignore it. It's just a constant. You could show dividing it on both sides if it bugs you being there, but you can just kind of like throw it away at this point. So divide by 3, that's gone. And either your x plus 7 is equal to 0 or your x minus 4 is equal to 0. I'm really running out of space here. So x is negative 7 or x is 4. All right, last one. It's only 2 terms again, and I do not see a perfect square. So let's go ahead and divide out whatever we can. Let's look for greatest common factor. So I can divide them both by 6 and x. Now this, I wouldn't want to just divide on both sides and throw away because there's an x in it. So that's going to give me an answer. X's give me solutions. They are not constants. I cannot just like divide them out and throw them away. What I'm left with is x squared minus 24x divided by 6x is 4. So I have perfect squares again. X squared is a perfect square. 4 is a perfect square. So I need to keep going. So square root of x squared is just an x. One's positive, one's negative. It doesn't matter which order. Square root of 4 is a 2. So now I've got to do 3 different zero product properties. Either 6x is equal to 0, x minus 2 is equal to 0, or x plus 2 is equal to 0. And so my answers are x is 0 or 2 or negative 2. It's got to be one of those 3 things. So this was a lot of information. These notes are really pretty long. Hopefully when you refer back to them, you won't have to watch the whole thing. But it is meant to kind of review everything from factoring. Do not forget about greatest common factor. That's like the biggest thing I see students kind of forget about that, and then it makes a more difficult problem. So as always, if you need help, please ask. There's lots of resources for factoring out there.